Hello, students. Today we will discuss the M files, the MATLAB files for the trapezoidal rule and the Simpson's rule. We all are aware that the trapezoidal rule and the Simpson's rule are used for numerical integration, right? So let me quickly go through the formula for the trapezoidal rule, and then we will open the M file. Okay, we know that it is actually the area under the curve, right? So here is the standard formula for the trapezoidal rule. We say that we divide the area into small patches and then we add it up, and we say that the functional value at the starting point, functional value at the ending point, and 2 times the sum of the functional values at the remaining points. Okay, for example, if n is equal to 4, what will happen? If step size is 4, number of grid points is 5. Okay, so the functional value at x1, functional value at x5, and then plus 2 times functional values at 2, functional value at x3, functional value at x4. Okay, 2 times. So now let us take a look at the M file. How would it look like? And I will share with you the M file. Okay, or you can pause the video and type it by yourself. Okay, this will be helpful for yourself. You will gain confidence to type your own M files by yourself and to learn the syntax. Okay, so up to you. You can either, I will share the M file with you, you can load the M file. Where will you place it? You will put it in the MATLAB folder in your documents folder. Okay, otherwise you can type your M file and save it with a unique name. Here I have saved it with traps1. First line is function. The left hand side is always the output, right hand side is always the input. Starting value A, ending value B, number of patches. N stands for number of patches, and the number of grid points would be n plus 1. All right, keep it in mind. FCN stands for the function. H is the step size, b minus a divided by n. X of 1 is equal to a, x of n plus 1 is equal to b, and for j is equal to excuse me, j is equal to 1 is to n. Now what is happening here? You have a nested loop. You have 2 for loops. In the first loop, what are you saying? You are saying that you have defined the x values. We all are aware that if, let's say, x naught is 0, or the starting a is 0, then the next value would be a plus h. For example, h is 4, let's say a is 0, b is 4, and n is 4. Then what is h? H is 1. Okay, then if a is 0, then a plus h is 1. Okay, so this is what we mean to say by line number 7, the command 7. So you are telling the software using a loop, using this syntax that using the index notation, that every upcoming x value is the previous x value plus the step size. All right, and this process will continue until you reach the last value. Okay, next you can see here that we have changed the index, not 1 to n, but we are saying 2 is to n. Okay, so the first value we have skipped. Why? Because we will use it later in this function, in this formula for the trapezoidal rule. You can see functional value at x of 1, functional value at x of n plus 1, and 2 times sum of y. Now what is this y? Y is the functional values at all the other points, just as we have discussed here that the trapezoidal rule is the functional value at the corner points with 1 coefficient and the functional value at all the other points with 2 coefficients. So to type it in the MATLAB syntax, we have used a loop. We have informed MATLAB that whenever we are talking about those functional values, we are calling it y, so that we can easily multiply it with 2. Okay, and sum means that all the summation of all these y values. Okay, now let us use this function here in the command window. Okay, so let us type the function. let me say that the function is a very easy function, x square. We all know that its integral is x cubed by 3, right? Analytic answer, when we apply the limits, we will get the analytic answer, right? So now let me define the limits of the integral. The lower limit is 0, upper limit is 4, the number of gray patches is 4. Okay, now I will apply the trapezoidal rule. Okay, so the inputs are lower limit of the integral, upper limit of the integral, number of patches, and the function. You can see the numerical answer is 22. We want to find the analytic answer. Since the function is very simple, integral of x square is x cubed by 3, and when I apply the limits from 0 to 4, what will happen? I will have 4 cubed by 3. So 4 cubed by 3 is actually 21.3333, right? So now my numerical answer is not as good, right? And it is not very close to the analytic answer. Now let us learn the mfile for the Simpson's 1/3 rule. What will happen in the Simpson's 1/3 rule? We will have a function here. Okay, this is the output. Okay, on the left hand side. On the right hand side, I have used a unique name. You can use your surname here and then save it with the same name, call it with the same name. Okay, now I have a function, start lower limit, upper limit, n. Okay, in the same manner, now here you can see I have not used a nested loop. On the contrary, I have here used the indices in a different manner. Okay, so please do compare the syntax of trapezoidal rule and Simpson's rule for learning. Okay, now you can see here that I've said area is equal to h by 3 sum of the coefficients times y. Now I have defined here the coefficients in a unique manner. Instead of defining the y values, I have defined the coefficients of the Simpson's rule. Okay, we all know that Simpson's rule has got a different formula. Okay, so let us read the Simpson's formula. Here you can see that we have different a table of different formula. Okay, here, this is the standard formula for the Simpson's rule, right? So you can see that for the odd functional values, you have got the coefficient 4. For the evens, you have got 2. And for the other boundaries, you have got the two boundaries, you've got the coefficient 1. Okay, so that thing we have used here, that knowledge, and we have designed the coefficients according to the index. All right, so now let us apply the Simpson's rule mfile on the same problem. Now, same starting point, same ending point. A is 0, B is 4, N is 4. Okay, and function is the same function, right? So let me type here N. You can see that the numerical answer is exactly the same as the analytic answer. So the Simpson's rule is better. Okay, now please solve some more questions and the other quiz task using the M files to compare your numerical answer, like handwritten answer, with your software answer, MATLAB answer. Okay, thank you.